So in this question, we have a target that is flying horizontally across the sky with a constant velocity of 10 meters per second. And we know the target is 50 meters above the ground. We also have a toy rocket, which can accelerate at 10 meters per second squared. And what we want to do is launch this toy rocket straight into the sky so that it hits the target. But in order to do this, we have to know how far should the target be from the rocket when we launch it. If you're confused by the question, let me make it a little bit more clear. So if we have this target and we have the toy rocket, and we launch the rocket right when the target is directly above it, because the target is moving, by the time it takes the rocket to reach the target, 50 meters above, the target will have already moved past where the rocket is, and the rocket will not strike the target. Now let's think about what happens if we launch the rocket when the target is not directly above it. Because the target is moving, by the time the rocket has reached 50 meters in height, the target will be exactly above it, and the rocket will strike the target. And that is the goal of this question. We need to figure out how far the target needs to be from the rocket for the rocket to hit the target after it's traveled 50 meters up. We always start by looking at what was given. Let's start our discussion with the target. The target is moving with uniform motion, and I know this because it's moving with a constant velocity. Because the target is moving with uniform motion, we know we can use the uniform motion equation, which says v is equal to delta x divided by delta t. We know the velocity of the target is 10 meters per second, and delta x is actually what we're solving for. It's the distance between where the target starts and where the rocket strikes it. Now you may be wondering about delta t, and to kind of spoil the ending, I'll tell you that delta t is what connects the target to the rocket. Because the two objects are moving separately, so the target is moving with its own velocity and it's moving in its own direction. Same goes for the rocket. But what connects them both is the fact that they're both moving at the same amount of time. So the time it takes the target to move a distance of delta x is the same amount of time it takes the rocket to launch 50 meters up. So ultimately, we will solve for delta t for the rocket and then use that to plug into our target's uniform motion equation and solve for delta x. So now let's look at the rocket. We were told that the rocket accelerates at 10 meters per second squared. Now it may not seem obvious, but we have more information than that. We also know the initial velocity of the rocket, and that would be 0 meters per second. I know that because initially the rocket is just sitting on the ground. It's not moving. It speeds up because we launch it and the engine accelerates it up. And then we also know the rocket's change in position, delta y, and that would be 50 meters. And I know this because we want the rocket to travel 50 meters up in order to strike the target. And notice I use the y variable because the rocket is moving up and down along the y-axis, whereas the target is moving left and right along the x-axis. That's why the target uses the x variable. So you can think of the rocket's initial position, yi, as 0 meters because it's on the ground. And then the rocket's final position, yf, is 50 meters because it's up in the air striking the target. So now we know all the information that was given to us in this question. It's time to figure out what equations we need to use in order to solve. Well, I had already mentioned that we can use the uniform motion equation for the target because it's moving with a constant velocity. And we know that delta x is what we're solving for. So we can quickly rearrange this uniform motion equation to isolate for delta x. Once we do that, we get delta x is equal to v times delta t. Now we know the velocity of the target. It was 10 meters per second, but we don't know delta t. So what we're going to do is use the rocket to solve for delta t. And the way we're going to do that is to find a kinematic equation for the rocket that gives us delta t. It's important to recognize that we do not have vf, the final velocity of the rocket. So we can't use a kinematic equation that includes vf. That means we have to use the YF is equal to YI plus VI delta T plus 1/2 A delta T squared kinematic equation. When we use that equation, we can see we have YF, we have YI, we have VI, and we have A, which means the only thing that's left to solve for is delta T, which is the variable we want. And what we're going to do is we're going to solve for that delta T using this kinematic equation and then plug that in to our uniform motion equation for the target. And that is how we're going to solve for delta x. So on a clean sheet, I've written out all our known variables and the equations we need. So we have our kinematic equation at the top here. And normally I would rearrange and isolate for the variable I want, delta t. But in this case, I want you to just plug the numbers in right away, because what you'll realize is we have a lot of terms that will just go to zero, because our initial position is zero and our initial velocity is zero. It will make rearranging a lot easier. So after I plug in all my values, the only variable I'm left with is delta t squared. And so all I need to do is isolate for delta t squared, do the math, and what we find is that delta t is equal to 3.2 seconds. Now this is not our answer. The question had asked us, how far should the target be from the rocket when they launch it? So what we need to do is take this delta t value and plug it into our target's uniform motion equation. And then we can solve for delta x. And we just need to plug in our velocity and delta t values. So we know the velocity was 10 meters per second, and we just solved for delta t, which was 3.2 seconds. And what we find is that delta x is about 32 meters. And that's our answer. If the target is about 32 meters away from the rocket when we launch it, the rocket will strike the target.